We're looking at sketching a cardioid here with this equation. And sometimes when we have to do something like this, it can be really helpful as a guide to first of all sketch a graph of r and theta like this, and then we'll translate it across to our final plane. So the graph of 1 minus sine theta, first of all, it is a negative sine theta, so it's going to look something like that. And then it's lifted up 1, which means our midline is going to be at a value of 1, r equals 1, and then I'm going to translate this up. So it'll end up looking something like that. And it means that now I can use my green line to sketch from here. I can see that when theta is 0, r is 1, which means when my angle, remember theta is my angle from the positive x-axis going up. So when my angle is 0 on my x-axis, my distance is 1. I'm going to draw a tiny little dot there. Then the next point I might be interested in here is when I start moving, you can notice my angle gets bigger. And as my angle gets bigger, because I'm moving to the right, my distance decreases. So as I move up, my distance decreases. So it's going to look maybe something like this. And then when I get to the y-axis, you can see my distance here is 0, and I'm at pi over 2 on the angle. So my angle would be the y-axis because that's at pi over 2. Now it starts increasing again. And when I get to the angle of pi, my distance is 1. This point here is pi and 1, which means back here, I'm going to be at negative 1 because my angle is pi, which will take me all the way over to the negative x-axis. And so I'm going to have a shape that looks like that. Now my distance keeps increasing, and it keeps increasing and reaches a maximum of 2 when I'm at 3 pi over 2. So here at 3 pi over 2, which is my y-axis, I've got a distance of 2, and then it comes back smoothly, which means my shape is going to look something like that. And this is what a cardioid looks like. And it's called a cardioid because it looks like a heart. That's where we get words like cardio and so forth. So now the last thing I want to do is maybe put in my important coordinates. So now here I have a coordinate of 1 and 0. Here I have a coordinate of negative 1 and 0. And down here I have a coordinate of 0 and negative 2. And that's how I've turned this polar equation into a cardioid. Isn't that beautiful? If you found this video helpful, please subscribe or like. Thanks.